Yeah, thank you very much. I would like to give you a short overview about the step-by-step approach of EnerPHit refurbishments and share my experiences in the huge European project Sinfonia. Well, these are typical existing buildings in Innsbruck, but the situation is similar in Europe, and I think maybe also in parts of North America and all around the world. In Europe, we have a huge building stock from the 1950s and 70s, but also many buildings from the turn of the last century, 19 to 1920. Buildings in general are responsible for about 35 to 40% of the final energy consumption and 1/3 of the carbon emissions. The vast majority of the buildings are inefficient and energy consuming existing buildings that need to be prepared as quickly as possible for the time after the energy transition. So there is an urgent need for action. These existing buildings need a future-proof deep refurbishment. Well, there are many reasons for refurbishments. The most important is that components are at the end of their life cycle, but also new requirements of accessibility, space requirement, and increase of construction density, and so on. From our point of view, the retrofit has to fulfill the current and the future requirements of climate protection, which means a reduction of the greenhouse gas emissions. The dilemma of average quality is an important issue here. Refurbishments with only average quality do not contribute to effective climate protection. With today's typical component qualities, the global climate protection goals will be missed clearly. These diagrams were made by my colleague, Dr. Jürgen Schnieders, with District pH, a tool which was developed in Sinfonia as well, and can assess the energy balance of districts. You can see on the left-hand side 4 different calculations with different energy standards, and over a period of 50 years to find out which one is the best solution to reduce CO2 emissions after this period. And on the right-hand side is the accumulated CO2 emissions over the 50 years. And yeah, it has shown that the economical optimum, as the PACIFA standard, would be the best option to reduce the CO2 emissions. Let's have a closer look to this left picture. With the black line, number A, you see the current German requirements, business as usual. And with this approach, we can reduce a little bit the CO2 emissions. The gray line is the same energy standard, but with a higher renovation rate for the first 10 years. So you can see that we can get a big reduction of the carbon emissions, but we will end at the same point after 50 years. Then the next one, number C, this is the PACIFA standard. The lines start quite slow at the beginning, but afterwards we reach the best result after 50 years after this life cycle of the building. Well, a higher renovation rate and the EnerPHit standard would be the best option, but this was the comparison. What happens? What is the difference at the end between the increasing of the renovation rate and the EnerPHit standard for refurbishments? And well, our scientific studies clearly show that a good quality, that means PACIFAs or EnerPHit as a minimum standard, can lead to a result with which the global climate protection goals, at least with regards to the building sector in this project can be achieved. The best and fastest way would be, of course, to increase quality and the renovation rate together. But if this is not possible because of economic reasons or whatever, then the increase in quality is much more crucial for the success. So the statement, every energy saving measure helps to limit climate change is rather misleading. And deep refurbishment of existing buildings is a once-in-a-lifetime chance, and the future-proof quality is a must. Well, this is our PASSIFAS criteria for new build and also for retrofits. I think I do not have to go into details, as you are, or most of you as a professional and familiar with the criteria, but I would like to point out two tables out of this criteria, table 2 and 3, because we have two different ways to achieve the EnerPHit standard. Well, one sentence to the EnerPHit standard. The PASSIFAS standard for new build often cannot be feasibly achieved in existing buildings due to various difficulties. Therefore, we have the EnerPHit standard, the retrofit with the PASSIFAS components. And there are two ways to achieve this standard: through compliance with the criteria of the component method, which you can see in table 2, or alternatively through the compliance with the criteria of energy demand method, which is in table 3. Only the criteria of one of these methods must be met. The values correspond with the criteria for the certified PASSIFAS components in table 2, and the criteria must be complied with as an average value for the entire building. So, for example, if you have a look to the opaque envelope against ambient air and the exterior insulation, so the exterior wall insulation, and you are in a cool temperate climate, like in Austria, for example, you have to reach 0.15 watt per square meter in Kelvin for the average thermal envelope. All these characteristic values you can find in the PHPP in the verification sheet if you choose EnerPHit as energy standard and component method as EnerPHit verification method. Here you have a closer look. You see the criteria, and if you fulfill this criteria, and these values are average values for the entire envelope. Well, the climate zone to be used for the building's location is automatically determined on the basis of the chosen climate dataset in the PHPP. Here you can see these climate zones for North America, and the characteristic values for the component method depends on your climate zone. Well, and now let's go to this huge European funded, from the European Commission funded project, which is called Sinfonia, is the short version. It's called Smart Initiative of Cities Fully Committed to Invest in Advanced Large-Scale Energy Solutions. With more than 30 partners from 8 European countries. There are 2 demo projects, demo cities, which are located in Innsbruck in Austria and in Bolzano in Italy, quite close to each other. In Innsbruck, buildings with a total of about 66,000 square meters are being renovated according to the EnerPHit standard. Or to the EnerPHit retrofit plan, which I will show you later, for the step-by-step renovation. And in Bolzano, about 33 square meter treated floor area. So the ratio is about 1/3 and 2/3 in Austria. The renovations mainly in the field of social housing and in inhabited state in condition, so the people stay in their apartments during the construction work. But also we have 2 school or 3 school buildings, and all projects in Austria were carried out by the local property developer NHD and IIG, Neue Heimat Tirol und Innsbrucker Immobiliengesellschaft. Well, the reasons why a building cannot be completely renovated at once are very diverse. It may have financial reasons, for example, lack of sufficient capital assets or subsidies. It can have technical reasons because maybe there's an urgent need of renovation at the wrong time because other components are not at the end of their life cycle, or efficient products are at the time of the implementation not available. But it can also have legal reasons, like the main challenge in Austria, for example, the Rent Act, or other legal requirements that prevent deep renovations. But it may also have human reasons. Someone is not willing to renovate for personal reasons. This must also be accepted. Well, what you have all residential buildings in Sinfonia are so-called social housing projects. This means that the state or municipalities provides low-cost housing for people with low incomes. For this purpose, people are registered on a list and ranked according to a numerical system. In the case of an available apartment, these people can decide whether they want to move in or not. Yeah, the main challenges in Austria, as I mentioned before, is the Rent Act. For deep renovation measures. You need 75% of the tenants agreed to the measures. So this agreement is necessary. If you want to change something in the heating system or the domestic hot water distribution, you need 100% agreement. And you can imagine that this is nearly impossible. Tenant agreement is necessary for the construction works inside the apartment as well. If you want to implement ventilation duct, for example, inside the apartment, you need an agreement unit by unit, even if the property developer is the owner of the building, but the tenants can say, no, I don't let the worker in, and then it's not possible to implement the ventilation system, for example. Well, and the solution is, in case of no agreements for ventilation installation, for example, only step-by-step renovation is possible when the apartments are empty. When the people move out of these units, you can install the ventilation system. So you do it step-by-step, or in another case, the windows have been changed 10 years ago, for example, so they are not at the end of their life cycle. They can be changed in 15 or 20 years again, and therefore, in the first step, there are no windows changed in these projects, for example. Yeah, and the Passive House Institute, we launched a certification scheme for the step-by-step retrofits in 2015, I think, which is based on the EnerPHit standard. It requires setting up an overall retrofit plan, which describes the different steps which will be carried out immediately or at a later point of time. The plan clarifies, for example, the position of the air tightness layer and the insulation layer, as well as detail of connections of the building assemblies. And only with such a general plan, a stepwise retrofit will lead to an energy efficient EnerPHit building in the end. An online certification platform facilitate the exchange and organization of documents, and this is especially important for the long time spans until the last step is completed. The first step will be pre-certified. So this is not the final certification, EnerPHit certification. It's pre-certified, and only after the last implementation, when fulfilling the EnerPHit criteria, the EnerPHit certificate can be issued. Each individual step is calculated with the variant worksheet in the PHPP, and if you have a PHPP license, this EnerPHit retrofit plan, which is a separate Excel file, is included in this package. Yeah, this is how it looks like. The cover page of this EnerPHit retrofit plan. There is also a time schedule on the different time and measures, yeah, so you can have an idea what are the next steps and what is the final EnerPHit step to reach the goals. Well, this is one example after refurbishment in Sinfonia, which has been pre-certified. Yeah, these are the advantages, as I mentioned before. And now I would like to show you another example before and after the refurbishment. The viewpoint is the courtyard. As you can see, in that case, there is also a building extension on the top, so you can see it much better and from the street view. This is before and after the refurbishment. Only the existing building was part of the Sinfonia, but there is an extension on the top. 2 new stories were built. One part of the heat losses in existing buildings is due to the thermal bridges. In the past, balconies were mainly constructed as cantilevered concrete slabs or consoles without a thermal break. And to avoid these relevant heat losses after a renovation, there are 2 common possibilities. The first one, to wrap up the balcony slab into a thermal insulation, or the second one, to tear off the existing balconies and build a new thermal bridge-free construction. Of course, to close the open balconies with a glazing facade in the front, so the warm spaces as part of the heated building volume. As a third option would be, of course, the optimum, but this kind of changes, a room instead of balcony, are usually not conform to building codes, and also mostly the tenants don't want to give up their open balconies. So the first possibility is usually not really feasible, because there is not enough space in the floor construction, and also the new exterior wall insulation causes less balcony area, which is very hard to argue with the residents. So in the most cases of the Sinfonia projects, therefore, the second solution has been found as reasonable, as in project you see on the screen. The balcony construction was completely removed, and a new build and a nearly freestanding construction was implemented with only few connections to the thermal envelope. Here you can see the punctiform connection to the thermal envelope with the space in between for the insulation material, and only one additional row of pillars were necessary for the load-bearing construction of these balconies. Here you can see the cover page of the EnerPHit retrofit plan with the intermediate results of the steps. This ERP is, of course, the EnerPHit retrofit plan is, of course, a booklet with 20 to 30 pages with all information about the final goal of EnerPHit and how to reach it with the different steps. Information about the building assemblies, windows, ventilation, photovoltaics, and all the things, but also the remarks to the interrelation between the individual measures and steps are pointed out there. So you have to be careful if you change the windows and bring them into the thermal envelope, but you don't implement the thermal insulation and so on. So these interrelations are quite important. Yeah, and you can see the first bar is the existing building, and the first step, which will have been implemented in Sinfonia, are 65% new windows, because the other one are 10 years old, as mentioned before, and only 25% of the tenants give the agreement for the to be connected to the new ventilation system. So the second step, the next one, the third bar would be 100% new windows after 10 or 15 years. And the last one is the 100% implementation of the remaining ventilations. Yeah, and afterwards, at the end, we will reach the EnerPHit standard. Here is another example for the balcony situation. Yeah, there are two anchors for the balconies, new foundation, and completely new freestanding thermal bridge-free balcony during the construction work. Well, let's go to the ventilation. My personal experience is that the new ventilation concept represents the biggest challenge of a renovation in an inhabited condition in every respect. This requires the greatest intrusion into the apartment where the privacy is the most disturbed. This work takes the longest and causes the most dirt for the residents. And as I said before, in addition, according to the Austrian legal requirement, each individual resident requires the consent to be able for this refurbishment measure. And both property developers in Innsbruck try to minimize the installation effort and construction work. So empty apartments were used to optimize the construction time and pollution. And with these model apartments, the time for the construction in the apartments was reduced from initially some weeks at the beginning to only 5 working days per apartment. And this picture shows a space saving possibility to implement a centralized ventilation system with vertical air ducts. You can see here triangular breakthroughs in the stair landing make a vertical distribution system for supply and extract air possible, and without restrictions of the stair width, because yeah, we need to keep this 120 centimeters, but there is a remaining small space in the corner, which we can use for the duct system, for the vertical ducts. Yeah, and this is yeah, and here. So this is in the staircase, a public staircase, and here we can enter into the apartment through the wall and come in into this room, and these are the ducts, supply air and extract air ducts to the rooms with a suspended ceiling at the end. Yeah, for us in 5 working days inside the apartment. And that project is another solution. Another solution could be implemented due to the floor plan design and spatial requirements of the building. The supply air ducts could be integrated onto the outside of the exterior walls. An existing insulation of the wall allowed to complete the integration of the ductwork within the new insulation with reduced thermal bridge effects. And yeah, through this solution, the intervention in the apartments could be reduced to a minimum, resulting in a much higher acceptance and satisfaction of the residents. the supply air ducts, all the supply air rooms are on at the south, and all the extract air rooms are the north facade. So it was a luck to implement this situation as a centralized ventilation system on the roof. And there are cutouts of the existing. There are 80 millimeters. I think they are about 4 inches. Sorry for that. So I speak in metric systems without the IP units, but it's about 4 inches existing insulation material on the walls, and then they were cut out in the line of the duct system, and they are fully integrated. And then the new 20 centimeters, 200 millimeters new insulation material can cover all this ductwork on the facade. Yeah, one hint, but not going into details, because fire protection is quite different in every country and region. But of course, you have to pay attention to your local or national fire protection requirements. We have to implement here some fire protection elements by going from outside to inside through the wall. Here are the calculated energy savings. They are expected around 84% after the last step, with 100% retrofit rate all over the 11 buildings out of 18 from Sinfonia. So only 50,000 square meters have been calculated. But for us, not only the planning, but also the performance of the buildings in operation is very important. With our calculations, we want to simulate the real conditions of the buildings, and therefore feedback from measurements is very important for us. And my colleague Sören Peper has compared the PHPP calculations with the measurement results. And this project shows again how accurate and reliable the PHPP is. These bars match quite well, considering the boundary conditions and also the high range for the monitoring. The deviation is almost insignificant. So the 26.5 kilowatt hours per square meter and year is at the moment, so it's not the EnerPHit standard, but the first step at the real condition. So it's not the standard condition at 20 centigrades. So this is at the monitoring temperature. But why do the buildings performing so well? Because there is a quality assurance behind. Here you can see all the certificates or pre-certificates. We have two final EnerPHit certificates because they are school buildings and could be implemented 100%. And all other buildings are pre-certificates, pre-certified. Well, they are only issued if the exactly defined criteria have been met, and the quality assurance is the key to success. Well, and now I'm at the end of my presentation, but I have some slides at the end. If you are interested in the monitoring results of Sinfonia, please visit us at the International Basiphos Conference in September. An abstract has been submitted. Now we hope that it will be accepted by the Scientific Advisory Board. But we will have interesting presentations on high efficient refurbishments for sure. And if you are interested in the Sinfonia in general, here's the website. I can also put some other links into the chat box afterwards. And I would also recommend this very good free online handbook of the step-by-step retrofits, which was a result of this EnerPHit project. This was another European project before Sinfonia. You can download it for free. And we have also the building certification guide with a detailed explanation of the step-by-step approach. And and the last slide is about our new global campaign of the International Passive House Association and all its worldwide affiliates for 2021 with the slogan "Efficiency, the first renewable energy," using the hashtag efficiency first, combined with a competition where you can win prizes, for example, tickets for the conference. And it's still running until 1st of March, so just join in and visit our website. Thank you very much for your attention, and I'm happy to answer your questions. Thank you very much.